Wave optics, HCV and HOTS series. The question number 1, white light having lambda means wavelength 400 nanometer to 700 nanometer. If this light goes through the water whose refractive index is 1.33, what are the limits of the wavelength is there? So wavelength we have to find out in water between this 400 nanometer to 700 nanometer. So definitely wavelength in water, the first limiting case is equal to wavelength in air by refractive index. So first one is your 400 nanometer by refractive index is 1.33. So if we are going to divide, we will get the 400 by 1.33, that is around 300 nanometer. That is the wavelength in water. The first range 400 nanometer. The second one is the wavelength in air by the refractive index, same 700 nanometer by 1.33. If we are going to divide, that is 525 nanometer. So these two are the answer. So remember, if the wavelength you have to calculate in a particular medium, so then what happens? The wavelength in the air to the wavelength in that the refractive index in that medium. That's a very, very important formula. Another question, the optical path of a monochromatic light is the same. Optical path is same if it goes through 2 centimeter of glass or 2.2 centimeter of water. मीन 2 सेंटीमीटर ग्लास का थिकनेस है उसमें भी जा रहा है और 2.25 सेंटीमीटर थिकनेस ऑफ द वाटर किसी कंटेनर में है 2.225 सेंटीमीटर. But the optical path is same. So if the refractive index of water is 1.33, what is the refractive index of glass? So how we are going to solve this? You remember one very important concept is there. When light travels through a distance, say x, in a medium of refractive index mu, then its optical path will be equal to mu into x. Very important formula. Optical path is mu into x. That optical path is equal to mu into x. So here it is given that 2 centimeter of glass and 2.25 centimeter of water if the refractive index is 1.33 and the optical path is same. So we have to write mu into 2.0 centimeter is equal to mu 1 mu 2 into 2.25 centimeter. Here this you have to find out, this is given. So mu 1 is equal to mu 2 is having the value 1.33 into 2.25 by this 2 comes here, so that will be 1.5. That should be your answer. Mu 1 is equal to 1.33. Optical path is same, so mu x is equal to mu x. So mu 1 we have to find out like that. This another important question in which it is given, white light passed through a double slit and interference pattern is observed on a screen 2.5 meter away. Separation between slits is 0.5 millimeter. The first violet and the red fringes are formed 2 millimeter and 3.5 millimeter away from the central white fringe, central maxima. Calculate the wavelength of violet and the red light. The situation is we know in the case of the interference, here the slit is there, here the double slit, here the central maxima is there, central maxima, bright fringe मिलेगा यहाँ पर. So it is given that separation of the red and the violet and the red light will be there. So to solve this question, we have to remember for the first bright fringe, the distance from the central y is equal to lambda capital D by small d. First bright fringe, ये y होता था, so y distance from central, y is equal to lambda capital D by small d. That particular formula we have to use. So what is given here for violet? For violet, y is equal to 2 millimeter given. So 2 is equal to millimeter is equal to 2.5 millimeter meter by 0.5 millimeter into lambda. Which formula? Same. Y is equal to lambda capital D by small d. So this we can find out the value of lambda by equalizing the unit. That is in nanometer we are finding, lambda is equal to 400 nanometer. For red light, y is equal to 3.5 millimeter given. So again 3.5 is equal to 2.5 meter into lambda by 0.5 millimeter. So in the nanometer we have to write in this way. In nanometer it is coming out to be 700 nanometer. That will be your answer. So remember the very important formula, lambda capital D by small d is equal to y, the position. Right. Another question, the intensity of the light originating from first slit is double that of the second slit in YDSE, Young's double slit experiment. Find the ratio of the maximum intensity to the minimum intensity in the interference pattern. So here it is given that intensity from this slit, intensity from here is I, intensity from here is double of that. So we have to, what we have to do, we have to find this. So if the intensity are double like that, we know one very important for intensity is the square of the amplitude, directly proportional to the square of the amplitude. So if the intensity is like that, so amplitude first one and the second one should be if I'm going to remove the square, so what will happen? Under root I directly proportional to A, like that. So A1 will be of A1 will be root 2, and then this one A2 will be 1. That means these two are in the ratio root 2 is to 1. Intensity double means what happens? Intensity double means twice of intensity directly proportional to square of this. So like that A is directly proportional to under root 2I. So like that only, root 2I. So we can say the first amplitude is your A1, second is your 1. So we have to find the ratio of the maxima to the minima. Maxima to minima. So how to find that? We know if the amplitude is there, For the maxima condition is your amplitude first one, second one whole square. For the minima, a minus b whole square. A and b are the two amplitudes, two individual amplitudes. So here the ratio of maxima to the minima will be root 2 plus 1 whole square. Say a is your original amplitude, like that. If you are taking out the common, like that, root 2 minus 1 whole square a. So ultimately it is 34. That should be your answer. Just you calculate and you will get the 34. That should be the ratio. Another important question, the width of one of the two slits in YDSE is double that of the other slit. Width is double. In the last question, that is your intensity double. As amplitude of the light coming from slit is proportional to the slit width, find the ratio of the maximum to the minimum intensity in interference pattern. So here width is like that. First one is say like that, and the second one is this. पहला का width है, दूसरा का width ये है. मान लेते हैं जो नैरोवर जो पतला स्लिट है उससे एम्पलीट्यूड निकल रहा है ए, इससे एम्पलीट्यूड निकल रहा है ट्वाइस से. सो ए मैक्सिमम ए मैक्सिमम कितना हो जाएगा, ट्वाइस ए प्लस ए, दैट इज़ योर 3a, एंड ए मिनिमम विल बी ट्वाइस ए माइनस ए, दैट इज़ योर ए मैक्सिमम. ए मिनिमम क्यों निकाल रहे हैं, क्योंकि हम लोग को इंटेंसिटी का रेशियो निकालना है, एंड इंटेंसिटी रेशियो इज डायरेक्टली प्रोपोर्शनल टू स्क्वायर ऑफ द मैक्सिमम एंड मिनिमम एम्पलीट्यूड. ए मैक्सिमम इतना हो जाएगा, ए मिनिमम इतना हो जाएगा. सो आई मैक्स बाई आई मिन इज इक्वल टू ए मैक्स स्क्वायर बाई ए मिन स्क्वायर. कितना कितना हुआ, 9a square by a square, that is your 9/1. That is your answer.